Guys, looks like we got a good amount of participation. Let's just go ahead and go over this because we have a lot to cover today. All right, so I saw some of you were posting on the whiteboard grams with your answer, but I just want to let you know that we're not really working with a molar mass as of yet. What we are doing is that we're just looking at the large coefficient and seeing that that is equivalent to how many moles we are making or using of the reactants or products. So because there's a large 4 in front of iron, we have 4 moles of iron, okay? And then for tripling the amount of iron produced, right? Think about like you're making a recipe for 1 cake, right? Instead, if I want to make 3 cakes, all I do is that I triple the ingredients, but if I triple the ingredients, I also get triple the amount of cake that I make, right? So we just multiply every large coefficient by 3, and it becomes 3 times as large. All right. So if there's questions on that, just let us know. Let's move on. All right. Please don't share any personal information during class. Your participation is still required, and we are recording these sessions for learning purposes. All right. Today is Monday. Still storming through Unit 4, working with Part 2 of one-step stoichiometry. All right, in which we will use the ratios between moles to complete calculations. All right, we're going to work with that a little more, and then we're going to expand that to using the molar mass to calculate grams or moles of a substance and converting between the two. All right, so let's go ahead, take our notes. Do we have the links? Okay, thank you. Forgot about that. Yeah, so either use my link or the Larkin link. Let's get our notes quickly out because we have a lot to cover again.
Okay, good. I just sneezed, so that's a good thing. All right, I am going on maternity leave at the end of this week, and I will not be returning for the remainder of trimester 3. So this is a quick reminder that I am having office hours every single day for the next 2 weeks at 2 p.m. Or sorry, for the rest of the week at 2 p.m. to help with projects. Remember, highly recommend that you have all 3 of your projects submitted before I leave. Junkwheel, go ahead and try the other link. There are 2 links. One will work, one won't. So if one doesn't work, try the other one. Highly recommend that you have all of your projects done before I leave. That's the Unit 1 food project, Unit 2 element project, and the Unit 3 friendship project. Because again, once I leave, we won't have those office hours to help you as much. So please make sure to come to office hours, get those done. I want to be able to support you. As much as possible before I do leave. Remember that the Unit 4 project is being replaced with the Unit 4 exam. The reason for that is we just don't know what the sub situation is going to be, and so to make sure that grading is easier if subs come in, this will make life a little bit easier. And then the final exam is still a final exam, so that has not yet changed, or that will not change. All right, let's go ahead and do a quick brainstorm. In the chat, what are the 2 possible mole ratios for the relationship between silver oxide and silver in this equation here? Remember that equations can represent either small atoms and molecules or big moles. And we've been talking about using moles now because moles are something that are a little bit more useful. They're actual amounts that we can actually see and work with in like a lab or a factory, okay? So taking a look here, moles of silver oxide. How many moles of silver oxide do you see in this equation? Take a look at its coefficient, big number in front, and tell me in the chat. How many moles of silver oxide do you see here? Thank you, Landon. Thank you, Monse. Yes, awesome. We should see right here 2, perfect. And how many moles of silver then do you see in our equation? So taking a look up here, take a look at its coefficient. Yeah, absolutely. Thank you, Landon. Thank you, Ronnie. Thank you, Micah. Thank you, Jonquil. Yes, we should see 4 right here. Perfect. Now, this is really useful because when we are doing stoichiometry, we might want to convert from one chemical to another. Remember that what you put on top is what you are converting to. So in this instance, I would be converting to silver oxide and from silver on the bottom. So converting to goes on top, converting from goes on the bottom. But let's say I want to switch it up. Let's say that I know how much silver oxide I have and I want to solve for silver instead. Remember that you can actually flip these numbers, right? So you can flip this so that now we have the 4 moles of silver on top and the 2 moles of silver oxide on the bottom. And these are things that we can actually use in our stoichiometry equations. Smiley faces, emojis in the chat if that review makes sense from Friday. We're going to go ahead and practice it. and apply it today. Smiley faces, emojis. Excellent. All right. So let's go ahead and talk a little bit about those mole ratios.
Mole ratios a bit right here. Remember that we can use the relationship between moles in a chemical reaction to convert from one chemical to another. So we can use, let's say, if we have a starting amount of hydrogen, right, we can calculate how many moles of water we would get out of that amount of hydrogen, or we can calculate the equivalent amount of O2 we would need to make the normal amount of water. So the way we do that, remember, is that whatever we're converting to, so what we need to find goes on top, where whatever we start with or what we're converting from goes on the bottom. And then for our examples here, the top ones switching between hydrogen and oxygen, those are obviously used to convert between those two molecules in the equation. Same thing goes for the H2 with the fraction of water, and then water in a fraction with oxygen. All right. Again, they're flip-flopping because you can go backwards or forwards when it comes to converting moles. All right, give me a quick poll with the orange check, or I'm sorry, green check or orange X, if that makes sense.
All right, so let's go ahead and put it into action. Again, this should be review from Friday, but just in case you weren't here or if you need some more review, we can go ahead and go over it. So the question is, when propane C3H8 is combusted, that means lit on fire, how many moles of oxygen O2 are needed to produce 10 moles of water H2O? All right, so taking a look here, what is my known? I need something that has a number, a unit, and a chemical. So tell me in the chat from my question, where do you see a number? And once you find that number, give me the number, the unit, and the chemical. Tell me in the chat. Micah, log out and back in. Yeah, if your screen is blank, log out, back in. Awesome, there we go. Thank you. I see Landon in the chat. Let's get some more answers. All right, we see that number 10. No, we should see that number 10 right here. And then go ahead and include what's the units and what's the chemical. Units and the chemical. Tell me in the chat. Awesome. I see Landon in the chat. Let's get some more answers. Yeah, we've got the chemical. John Queel, awesome. Thank you, Dima. Yeah, exactly. So 10 moles of H2O, right? So 10 mole H2O. And I want to turn this into a fraction. So what number can I put it over to keep it the same, but in fraction form? Anything divided by what will still be itself? Yeah, just divide it by 1. Now it looks like a fraction, but it's still itself. Great. Now in the next step, I want to get rid of these units, moles of H2O. They're on top right now. To get rid of them on the next step, they need to go on the opposite side. Which is the opposite side, the top or the bottom? If they're on the top, where does it go in the next step? To be on the opposite side. Thank you, Landon. Thank you, Ronnie. Thank you, Micah. Let's get Douglas and Callie in the chat. Let's get John and David in the chat. Jaden. There we go. Yes, it needs to go on the bottom. So moles of H2O goes on the bottom. That's what we're converting from. What we're converting to needs to go on top. So we're converting to goes on top. Take a look at the question words. How many what? Give me units and chemical. Units and chemical. What am I solving for? Question words up there say how many what? Yeah, we've got moles, but moles of what? I say Landon with both units and chemical. Ronnie telling me units, but let's get the chemical in there too. Again, let's get lots of participation. Thalia, Elijah, Kathy, Gustavo, Karime. Yes, thank you, Micah. Awesome. Narish, Ali, get your answers in the chat. Peter. Josiah. What are we solving for? Moles of what? Yeah, moles of oxygen. So MOL space O2. Beautiful. All right, so let's go ahead and now take a look at filling this in. Remember, anytime we fill in a conversion ratios always have to come from something that is standardized, meaning something that's always true. So you don't fill in the conversion ratio based on the question. You're actually going to fill in the conversion ratio based on the balanced equation, because the balanced equation is always true. Taking a look here, how many moles of O2 are in the balanced equation? Take a look at its coefficient. Tell me in the chat. How many moles of O2 are in the equation? Thank you, Landon. Thank you, Ronnie. Take a look at its coefficient. Hello. Yes, David. Awesome. Yeah, 5. Thank you, Kathy. And how many moles of H2O are in the equation? Take a look at its coefficient. 4. Beautiful. Now we have our equation set up. That's the hardest part. Now we just need to solve it. So this is easy. We multiply across the tops, the numerators, multiply across the bottoms, the denominators. So on top, what is 10 times 5? On the top, what is 10 times 5? Excellent. Thank you, Peter. Thank you, David. Awesome. Get your answers in the chat. What is 10 times 5? Excellent, Thalia. Yeah, it's going to be 50. And on the bottom, what is 1 times 4? 1 times 4 absolutely equals 4. Now this is a fraction, but fractions again are just division in disguise. So do the top divided by the bottom, 50 divided by 4. Grab a calculator if you need it and tell me what do we get. You will need calculators for the next one because the next one is an application problem, one that you need to finish on your own. So make sure you know how to use your calculator. Yeah, 12.5, and don't forget we need to analyze our units. So we got rid of moles of H2O because they're on the top and the bottom. All I'm left with is moles of O2 right here. And is that what I was solving for? Yes or no? Moles of O2? Is that what I was solving for? Moles of oxygen, where it said how many? Yeah, moles of oxygen, moles of O2. Awesome. So that's our final answer here. Please fill in number 2. First box is going to be 12.5. Second box is going to be the units, which should be MOL space C3H8. Don't have to do anything special with the numbers in the chemical, just C3H8 exactly as you see it in the chat. This is number 2. Go ahead and raise your hands. You have 20 seconds to fill that in. Go, go, go. All right, so this one is a complete on your own. I'm going to help you annotate and set up the equation though. So the question is, how many moles of sulfur trioxide, SO3, would you produce with 6 moles of oxygen, O2? Here's our equation here. We have sulfur plus oxygen giving us sulfur trioxide over here on the right. Let's take a look here. What am I starting with? What do I know? Give me a number, unit, and chemical. Where do you see a number? And then include its units and chemical. Tell me in the chat. Find a number. What number do you see in the question? And give me also the units and the chemical. Excellent. I see Landon coming in here. Let's get some more answers. Again, take a look at the number and then include the units as well as the chemical. Thank you, Micah. Awesome, Ronnie. Yeah, so 6 moles of O2. MOL is our abbreviation for moles. O2 is our abbreviation for oxygen. Turn it into a fraction by putting it over what? Turn it into a fraction by putting it over what? Yep, over 1. That doesn't change it, just makes it into a fraction. In the next step, I want to get rid of moles of O2, so where does it go? What's the opposite side? It's on the top, so where does it go in the next step? Beautiful, yes, on the bottom, down, yes. And on top needs to be what I'm solving for. Take a look here. What am I solving for? Give me units and chemical. Units and chemical. Question is how many what? How many what? It is not moles of S. That would just be sulfur. Sulfur something different. All right, you are right that it's moles, but moles of what? Read the whole part, all of it. There we go. I see Micah. I see Thalia. Yeah, it's actually moles of sulfur trioxide. So MOL space SO3. That is what goes on top. Smiley faces emojis in the chat if you feel comfortable with that. Smiley faces emojis in the chat if you feel comfortable with that. It says moles of sulfur trioxide, not just sulfur. Sulfur, something different. Beautiful. All right, now we need to go ahead and fill this in. Again, it needs to be filled in from something that's standardized or always true, which is our balanced equation. How many moles of sulfur trioxide are in the equation? How many moles of sulfur trioxide are in the balanced equation? 8, perfect. And how many moles of O2 are in the equation? How many moles of O2 are in the equation? Yeah, beautiful. 12. So here we go. On top, I've got 6 times 8. Don't put answers in the chat. On the bottom, I've got 1 times 12. Do not put answers in the chat. So at this point, you should be able to finish up the calculation. I do want to go over the units, though, really fast. Remember, we got rid of moles of O2, and what I'm left with is moles of SO3. And is that what I'm supposed to be solving for? Tell me in the chat, yes or no. Taking a look back at our question, are we solving for moles of SO3? Yeah, absolutely. SO3 is our sulfur trioxide. So again, our first box here should be the numbers 6 times 8, do 1 times 12, and then do the top divided by the bottom right here. And then our second box should be MOL space SO3. So this is going to be number 3. Go ahead and work on that one. You have 30 seconds if you want to check your answers. I'm in the Q&A box.
I use it later on. Use your colored pointers. I just nailed your whiteboard tools. Use those colored pointers. Point to, for me, where you see the molar mass. Lower number that has the decimal on the end. So for xenon, it's going to be 331.29, and our units are always going to be grams per mole. And notice how we have a slash in our units. That means we can use this as a conversion factor, which we will do right here.
Perfect. Okay, so far we've been converting from moles to moles, right? But now we can actually also convert from moles to mass, or mass to moles, the reverse, by using molar mass. And the reason why is because molar mass includes both moles, hence the word molar, and mass, hence the word mass, all right? So this can actually be written as a conversion ratio or as a fraction as well. Take a look here. We just learned that the molar mass of xenon is 131.29 grams per mole. The slash means per. All right. Now, however, this slash is a division sign, which means it can also just be rewritten as a fraction. Okay. So this is the same as putting grams all over moles. However, we do need to figure out the number here. Again, taking a look here, there is no number next to moles. It's blank, and blanks mean what? Tell me in the chat. Blanks mean what? Yeah, blanks just mean 1, so I can just plug in a 1 right here. So now you can see here, I've got 131.29 grams of xenon divided by 1 mole of xenon. And again, this is just a fraction, so I can put 131.29 grams of xenon divided by or over 1 mole of xenon. Smiley faces, emojis in the chat if that's beginning to make sense. Again, these slashes are actually just division, which can be rewritten as fractions. And we can use those as ratios because these are always true. These are standardized. Cool. So taking a look here, remember that we can also flip these depending on what we're solving for. So if I want to solve for mass, then grams goes on top. If I want to solve for moles, then moles goes on top. But as always, it's going to be easier to practice it. Let's go ahead and fill in number 4 really quick. Number 4 is the word ratio. 20 seconds. Raise your hands. So as always, much easier to actually begin to use it. So the question is, how many moles is 200 grams of xenon? Take a look here. What is my number? And give me its units and the chemical. Units and the chemical. Be careful here. We have some new units here. We're not just talking about moles now. We're not just talking about moles. Tell me in the chat. Give me the number, the units, and the chemical. What is our known here? There's only one number in the question. Awesome. I see Micah. Micah, it's actually just grams. It's just grams. So 200 grams of xenon. There we go. Let's go ahead and get that in the chat. Everybody, everybody. There we go. Fixing it. Love it. Yeah, so we're going to start off with what we know here, which is 200 grams of xenon. Beautiful. And I'm going to put that over 1 just to turn it into a fraction. In the next step, I want to get rid of grams of xenon. So where does it go to be on the opposite side? Everybody should know the answer by now. Yes, it goes on the bottom. Perfect. And on top is what I'm solving for. Take a look here. What am I solving for? Look at the question words. How many what? How many what? Again, you will need to be able to do one of these on your own, so make sure you're practicing with us. Yeah, exactly. We're solving for moles, and this time it's not changing chemicals, so it's actually still the same chemical. It's still xenon. So MOL space XE for moles of xenon. Now again, when we fill in our conversion ratios, it does not come from the question. It needs to come from something that's standardized or always true, and that is the molar mass of xenon. We know the molar mass of xenon from the previous slide we just said was 131.29. Again, that's just this number over here on the bottom. So plugging things in, what should go next to grams? Tell me in the chat. What number goes next to grams? Read the number next to grams. Nope. No, does not come from the question. It needs to come from the molar mass. Take a look where I'm pointing here. What number is next to grams in our molar mass? Has to come from something that's always true. You won't always have 200 grams of xenon, but the molar mass will always be, 131.29 grams. Perfect. And on top here, what number is next to moles? I have a blank. Blanks mean what? Blanks mean what? Yeah, blanks just mean 1. So 1 goes on top next to moles. So on top, I've got 200 times 1, which equals what? On top, I've got 200 times 1, which equals what? Yeah, it equals 200. On the bottom, I've got 1 times 131.29, which still gives me 131.29. Grab your calculators, do the top divided by the bottom, and tell me what do you get. Go ahead and give me 2 decimal places. 2 decimal places. Excellent. I see Landon in the chat. Let's get some more answers. And make sure you have your own calculator out. You will need to do one of these on your own. Make sure you're practicing. Yeah, beautiful. So we should be ending up with 1.52 as our number. And then you are correct. Units here, grams of xenon cancel out. I'm left with moles of xenon. And that is definitely what I was solving for. I was solving for moles of xenon here. So that looks beautiful. And so we now know that 200 grams of xenon is the same as 1.52 moles of xenon. That's our answer for number 5. First box, again, is just the number 1.52. Second box is going to be MOL space XE. Space XE. Number 5, raise your hands. You have 20 seconds. All right, so now we can actually also do the reverse, still using molar mass, because again, it includes both moles and mass. So this time the question is, how many grams is 3.2 moles of xenon? Tell me in the chat, what is my known? What am I starting with? What is my known? Give me number, give me units, give me chemical. In the question, where do you see a number? And then what units and chemical go with it? Thank you, Micah. Thank you, Landon. I see Dima. I see Monse. Let's make sure we get everybody in there. Mary Jane. Thank you, Andrew. Let's get Angelo and Kathy, Gustavo. There we go. Awesome. Yeah, so we're starting off with 3.2 moles of xenon. Gonna put that over 1. In the next box, where does moles of xenon go if I want to get rid of it? What's the opposite side? On the bottom, yes. And on top, what am I solving for this time? How many what? What am I solving for this time? How many what? Yeah, this time we're solving for grams of xenon on the top. And this is going to come from our molar mass. We said earlier our molar mass is 131.29. So tell me in the chat, what number should go next to grams? Again, this needs to come from our standardized molar mass, something that's always true. What goes next to grams on the top? Thank you, Landon. Thank you, Micah. Yeah, that 131.29. And on the bottom next to moles is what? We see a blank here. Blanks mean what? Blanks just mean 1, so 1 goes on the bottom. So this is pretty easy. On the top, I've got 3.2 times 131.29. Go ahead and tell me in the chat, what does that equal? On the bottom, I've got 1 times 1, which will just end up equaling 1. So on the top, what do we get? 3.2 times 131.29. You can give me 2 to 3 decimals. 2 to 3 decimals. Thank you, Andrew. Thank you, Landon. Excellent, Micah. Ronnie, perfect. Waiting on Mary Jane. Thalia, Elijah, Kathy, Gustavo, Karime, Andrew, Nareesh, Peter, Jaden. Yeah, awesome. So here we get 420.128. All right, that divided by 1 will still be itself, and so you should end up with 420. And the computer only needs 2 decimals, so 0.13 here. And units here are grams of xenon because we got rid of moles of xenon. All I'm left with here on top is grams of xenon. So first box here is going to be 420.13, and second box is going to be G space XE. Go ahead and raise your hands for number 6. You get one more practice problem, and then the last one we need to be able to do on our own, so work, work, work.
Strontium, right? So always what we know comes first. So what we know is 50 grams of strontium. So SR. All right, we're going to write that over 1, right, just to make it a fraction. And then our conversion ratio is going to come from some standard that they're giving to us, right? And the only standard that we have is, of course, the molar mass. So the molar mass is in grams per mole. So the grams per mole means we can turn it into a fraction, and that will be the grams going on the bottom. 0.62 grams of strontium. And then on top is going to be 1 mole of strontium to end with. So canceling out grams of strontium, right, we're going to be left with moles. And so now what we have a 1 here, a 1 here. Here we have our 50 grams of strontium. And then here we have our A7.62. And now I'm going to leave the rest up to you guys. Tell me, what is 50 divided by A7.62? All right, good. So our final answer is going to be 0.57 moles of strontium. Don't forget those units, moles, or it's going to be MOL space SR. All right. Do you see, guys, how we got rid of grams? We started with grams. The units we have for the conversion ratio go on the bottom, and so we cancel them out, and we're left with moles. All right, as always, first box is our numbers, second box is our units. Let's raise our hands for number 7, and then we will move on. And it should just become second nature eventually.
All right, so this last one, we're going to go ahead and annotate, and then you need to finish it on your own. So the question is, how many grams is 2.1 moles of strontium? Everybody in the chat, very quickly, tell me what is the number that I know, and include its units and its chemical. Tell me what number do we see in our question, and include its units and its chemical. Excellent, I see Landon. Excellent, thank you, Elijah. Awesome, there we go. Yeah, we're starting off with 2.1 moles of strontium SR, putting it over 1 to turn it into a fraction to make our lives easier. In the next step, moles of strontium's on the top. Where does it go in the next step to get rid of it? What would be the opposite side? Yes, always on the bottom. And on top is what I'm solving for. Take a look here this time. What am I solving for? What am I solving for? How many what? Yep, grams, and specifically, it's still the same chemical, so grams of strontium goes on top. Now again, we need to fill this out with something that's standardized or always true, which is the molar mass. Molar mass, remember, is this bottom number for strontium, so that's going to be 87.62. And taking a look here, what number should go next to grams on the top? What number should go next to grams on the top of my conversion ratio based on my molar mass right here? Thank you. I see Ronnie in the chat. Let's get Kathy, Gustavo, Kathy, Gustavo, Gustavo. Let's get Narish. Let's get Dima and Jaden and David. Awesome. Yeah, so 87.62 goes on top. And on the bottom, what number is next to moles? It's a blank. Blanks mean what? Blanks mean what? Yeah, blanks in our molar mass just mean 1. And so on top, do not put answers in the chat, but on top I've got 2.1 times 87.62. And on the bottom, I've got 1 times 1. Again, once you've solved the top and the bottom, all you have to do is divide the top by the bottom. Last thing here is don't forget units. Again, we got rid of moles of strontium. I should be left with grams of strontium on the bottom. So taking a look here, you should be able to finish up both the calculation as well as entering those units. First box, make sure that you have 2 to 3 decimal places, so point blank blank blank. And for your second box, again, units will be G space SR, grams of strontium. Go ahead and raise your hands for this last one. You have 30 seconds. If you want help, we are in the chat, Q&A chat. If you want to check your answer, we're in the Q&A chat.
Well as ratios between mass and grams, right? Otherwise known as the molar mass, to complete calculations as well and to convert. So great job on that. If you haven't submitted your notes already, go ahead and submit them. All right, you guys did a great job today. We will see you guys tomorrow. Take care. All right, go ahead and let yourselves out if you do not have any questions. Have a good one.